Good day, everyone. So today we'll be looking at exponential expression and exponential equation. Okay, so today we'll be looking at exponential equation, how to solve exponential equation. And we've done some work on this previously. This is a continuation of what we've done before. All right. Okay, so let me start again. Today, we'll be looking at exponential equation, and that will be the part 2, the second part of this question. So previously, we have looked at some examples of exponential equations. So this will be a continuation of what we've done before. I will work all these examples for you. Then I will leave you with some examples to do as well. Now, the first question, and when you're solving exponential equation, one thing you should always look out for is the base. So in this particular question, okay, let me pick at my snippet. My snipping tool, rather. So here, I'll just cut this out. So if you look at this exponential equation, the first thing you want to look out for is the base. So this 7 here is the base, and 7 here is the base. And what you have on top, these are called the exponent, or you can say power or index, right? So the most important thing here is to make the base equal on both sides. Now, sometimes you will have this base directly equal to each other, and at some other times, like in this case, you have to do some manipulation. All right, so let's get to it. In this first question, we have 7 exponent 2x plus 3, and everything equals 7 exponent 6x minus 1. All right, so here you could see that this exponent 7 is equal to 7 on the other side. This base, which is 7 here, is also equal to 7 here, which is also a base. Therefore, we cancel the 2 and we equate the exponent to each other. So in this case, we have 2x plus 3 equals 6x minus 1. At this point, we collect the like terms. We can bring this plus 6x to this side. Then we bring the plus 3 to this side. Remember, whenever any term crosses the equality sign in mathematics, the sign reverses. So here we have 2x. Then this plus 6 crossing to this side becomes negative 6x. Then that will be equal to negative 1. Then this plus 3 crossing to the other side becomes minus 3. So 2x minus 6x is minus 4x. Then this will be equal to minus 1 minus 3. I've already taught you how to do this. Minus means you are owing, right? So you owe 1 rand, for example, or you owe $1, you owe another $3. So in total, you will be owing $4. So that will be negative 4. And to do this, to find x, I've also taught you how to do this. You have to divide both sides by the coefficient of x. So that the coefficient of x here is negative 4. So you divide this side by negative 4, and you divide this side by negative 4. Negative cancels negative to become positive. 4 cancels 4. you are left with x. So x in this case will be equal to, here, negative divided by negative will be plus, 4 divided by 4 will be 1. So in this case, x is equal to 1. And you can evaluate your answer by evaluation. By evaluation, I mean you can substitute x for 1 anywhere you find x here. So let's look at it. Remember, the original equation is 7 exponent 2x plus 3 equals 7 exponent 6x minus 1. So let's substitute x equals 1 and let's see if we have the same thing on both sides of the equation. So this will be 7, then this will be 2. Then instead of you putting x here, you can substitute 1, then plus 3 equals 7 exponent 6 into 1, x equals 1, then minus 1. So here you have 7. 2 times 1 is 2 plus 3, that will be 5. And here we have 6 times 1 is 6 minus 1 is 5. So you can see on both sides we have 7 exponent 5 equals 7 exponent 5. So that is the proof that what you did was right. So we go to the next question. So the next question. So we are dealing with question 8 now. And here we have bracket 2 exponent 3, then exponent 7 minus 2x equals 8 exponent 2x minus 9. So here, remember the first thing you want to look out for when you're solving exponential equation is common base on both sides. So here the base is 2 raised to power 3, right? So you have this base here, which is 2, but you have the exponent, which is 3 here, and you have another exponent outside of the bracket, which is 7 minus 2. So what you have in this bracket is 2 to the power of 3, and if you do it very well, 2 to the power of 3 equals 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 equals 8. So that way, we can turn this 2 to the power of 3 into 8, right? Then we write this exponent. So that will be 7 minus 2x, and that will be equal to 8 exponent 2x minus 9. So now the base is the same on both sides of the equation. So this 8 cancels this 8. Then you have 7 minus 2x equals 2x minus 9. So we can collect the like terms. This 2x can come this way, and this 7 can come this way. So this will be negative 2x. Then this plus 2x after crossing the equality sign becomes negative 2x. And this will be equal to negative 9. By the time this plus 7 crosses the equality sign, it becomes negative 7. So here, minus 2x minus 2x will be negative 4x. That will be equal to negative 9. Negative 7 will be negative 16. And you know how to do this. You have to divide both sides by the coefficient of x. And the coefficient of x in this case is negative 4. So negative cancels negative. 4 cancels 4. Then you are left with x, which is what you're looking for. Therefore, x will be equal to minus divided by minus gives you plus. Then 16 divided by 4 is 4, right? So you can evaluate your answer if you so desire. So question 9. Here we have bracket 3 squared. Then we have 3x plus 1 equals bracket 3 cubed x plus 4. So here, it will not help us to convert 3 to the power of 2 to 9. That will not help us in this case, because if we convert 3 to power 2, 3 squared to 9, then here we might need to convert 3 cubed to 27. And 9 is different from 27, so they cannot cancel each other. So what we can do here is, if you remember the principle of indices, we can use this 2 to multiply this. So here, this 2 can multiply this 3x, then it can also multiply this 1. The same thing applies to this 3. It can multiply this x, and at the same time, it can multiply this 4. So doing that, we have 3, then we have 2 times 3x, that will be 6x. Then 2 times plus 1 will be plus 2. Right? Please note this. The questions like this come out. Then we have 3, base 3. Then 3 times x will be 3x. Then 3 times 4 would be 12. So you can see now that the base is the same on both sides. So base 3 can cancel base 3. 3 can cancel 3. You are left with 6x plus 2 equals 3x plus 12. So here, these 3x can come to this side, and this 2 comes to this side. Therefore, we have 6x minus 3x. This 3x comes to the other side. Then that will be equal to 12. Then this plus 2 comes to this side, it becomes negative 2. So here, 6x minus 3x will give us 3x equals 12 minus 2 is 10. And remember how we do that to calculate x. You divide by the coefficient of x. You divide both sides by the coefficient of x. 3 cancels 3. You are left with x here. Therefore, x will be equal to 10 over 3. And you can express this 10 over 3 as a mixed fraction. That will be 3 whole number 1 over 3. Or you can express it as a decimal, which would be 3.333. So it really depends on what your teacher wants, but this 10 over 3 is good. Then let's go to question 10. So I will solve question 10 as well for you. Then you will solve questions 11 and 12 yourself. So question 10. For this question 10, we have 4 exponent 2x, 4 exponent 2x plus 3 equals 16 exponent x minus 1. So here, remember, our first point is that you find a way to make this base equal on both sides. So you need to think of the similarity between 4 and 16. So in this case, you don't need to do anything to this 4, but you can think of converting 16 to its prime. You can write 16 as a product of its prime factor. In that sense, you convert 16 into a form that will have base 4. So here, we have 4 exponent 2x plus 3. Then instead of writing 16, 4 squared is also equal to 16, right? So you just write 4 squared there. Then remember, you have this x minus 1. So we have 4, 2x plus 3 equals 4. This 2 multiplies this x, then it also multiplies this one. So we have 2 multiplied by x, that will be 2x. Then 2 multiplied by -1 is -2. So the base is now the same on both sides of the equation, so they can cancel out each other. Now we have 2x plus 3 equals 2x minus 2. Wow. There's something wrong with what I did. Mm. Mm-mm. Okay. So it shows that this question is wrong, right? There is no solution because if we take these 2x to this side, it will be 2x minus 2x, right? Which will be 0. And here, if we take these plus 3 to this side, it becomes -3. So 0 cannot be equal to -5. So it means this question is wrong. There is no way 4 exponent 2x plus 3 can be equal to 16 exponent x minus 1. So that is the implication of that. All right, so that is the end. Remember, you will solve questions 10 and 12 yourself. All right.